function, I'm going to have to use implicit differentiation to find dy dx. So sometimes I like to do this. I kind of move my right side over a little bit so that I can have room to differentiate both sides. So I know I'm going to have differentiation of this with respect to x, and I want the differentiation of that with respect to x. Let's kind of make it a little bit nicer here. There we go. That's good. Okay, I think I can do that. I'm going to differentiate my left-hand side here first. So the derivative of, I'll put it even in parentheses. The derivative of x with respect to x is just going to be 1 plus, well, the derivative of sine with respect to x, we know the derivative of sine, so that's going to be cosine y times, because y is a function, dy dx. That equals, well, now here I have the quotient rule. I'm sorry, the product rule, which I just wrote over here. So I have the derivative of u, which is my x, that would be 1, times y, my v, plus u, which is x, times my derivative of y, which is, well, the derivative of y to the first would be 1 times dy dx. It's just saying the derivative of y is the derivative of y. So dy dx. Let's make it look a little bit nicer. I'm going to say this is dy dx cosine y. You know, I'm not going to say that. I'm going to just write it the way it is. I'm going to say it's 1 plus cosine y dy dx is equal to y plus x dy dx. Now what I need to do, I'm trying to find the derivative with respect to x. In other words, I am trying to find dy to dx. Well, dy to dx is going to be some kind of a number. So I want to get all the dy dx's on one side of the equation. So I'm going to put it on the left side. So I'm going to subtract from this side x dy dx, and I'm going to subtract it from here, minus x dy dx, and I end up with 1 plus cosine y dy dx minus x dy dx equals y. And I want to get those dy dx's all by themselves, so I'm going to subtract 1, and I'm going to get cosine cosine y dy dx, cosine of y dy dx minus x dy dx is equal to y minus 1. Then, just using my algebra here, I'm going to distribute, I'm going to undistribute dy dx. So I have dy over dx times cosine y minus x equals y minus 1. And I think I'll divide both sides of this by cosine y minus x. What I wind up with, that cancels out, and I wind up with my derivative of y with respect to x is equal to y minus 1 divided by cosine y minus x. And that is the answer. That is the derivative of y with respect to x. I want to point one thing out. The book says that the answer, and you have to be careful with this, the book says that the answer is 1 minus y over x minus cosine y. Well, you have, if you get an answer like I got, and you look at the book and you see they have a different answer, one thing you should always be aware of is they might really be the same. And if I just multiply this by negative 1 divided by negative 1, in other words, I multiply it by 1, I get negative y plus 1 over negative cosine y plus x, which, of course, is the exact same thing as that. I would not insist on this answer as over this answer. They're both equally acceptable. But just be aware that it might be something easy like that to bring your answer into compliance with the answer in the book.